students. I'm going to discuss today about the Unit 3. Unit 3 has some important things which is input-output organization, and in this unit we will study about that how we can interface our input and output devices with our microprocessor or microcontroller. So it is a very general expression, so general discussion about input-output interfacing with our microprocessor. So first of the topic is assessing input-output device, and another important topic is interrupt hardware, that how to deal with the interrupt hardware, how to deal with the interrupts, and then we have enabling and disabling interrupts, how to deal with the interrupts, it is important, and handling multiple devices maybe, so because we have many devices which are connected to the microprocessors, so we have handling multiple devices, and then we will see about the controlling device request. So multiple times multiple device requests are generated, and these must be handled by the microprocessor, so this is there. Some exceptions are there, and then direct memory access, some buses interfaces circuits are there, and standard input output interfaces, for example PCI bus, SCSI bus, and USB bus. So we will discuss all about the input output interfacing with the microprocessor. So this is the starting of our unit, and in this we will see that how we can work over the input output interfacing. So let's discuss it. So in input output organization, we can see that how we can interface our mic input output devices. For example, our keyboard, our mouse, our uh, uh, for example our monitor, some display units, some touch panels. These all things are the important things, and which are we will need to deal with the interface of our with our microprocessor. So let's see, it's assessing input output devices. So how we can assess these devices with the microprocessor is the important thing. So now see that this is a very general basic block diagram of in which we have bus, and this bus has the some important blocks, like for example processor, memory, input output device 1 2 and so on. So n devices may be controlled by means of the single processor, so that is an important thing. So input output devices are controlled by the processors basically, and so we have two things basically, that we have to read something from the devices, or we have to write something right to the devices. So for example, as in we have done in the memory, so in memory also we have to discuss about the memory locations, that from where we have to access the data, and now the data is given by the input output devices. So we have to read the data from the input output devices, or we have to write the data to the input output devices. So there are many ways in which we can do these things. So multiple, for example, multiple input output devices may be connected to the processors and the memory via a bus. So bus maybe any of the things, so it may be address bus, it may be data bus, it may be control signals. So we have some address bus for the address to generate the addresses of the devices. So some particular devices are addressed using the processor, and then we have the data, what kind of the data bus, so that we can assess the data, that we can write the data to the devices, we can read the data from the devices. And we have some control signals, for example read signal, write signals, or write signals, or we can say wait signals are also there. And some each input output devices is assigned as unique address. So if I have already told you that there's each and everything is in the computing system is located by means of its address, it's a physical address, that where is this assessing, where is this accessible. So the processor places the address on the address lines basically, and the device recognize the address and responds to the control signals. So it recognize the address, and particular address has the particular device, and this particular device is then works accordingly the control signals. So if it is read, then read will be provided, and if it is write, then write signal will be provided. So that is the thing. So for example, if we have input output, and so there are two ways basically that input output devices and memory may share the same address space. So it may be possible, yes, that may be possible that if same address space can be accessible by using the input output device and memory. So in this cases, the memory mapped, this is also known as memory mapped input output. Any machine instruction that can access memory can be used to transfer data to or from the input output devices. Simpler software, it can be used here. For example, move data in R0. If I want to read some data in is any register in the keyboard, and we have to access that this data from this register to the R0, so if we have to give a command, for example, move data in R0, so all the data in the data in register will be transferred to R0. So that's why I have created this kind of the arrow, and I have written this command here. So in the next case, we have if we want to display something, so what I have to do, I have some data in R0, and that I have to transfer to the display unit data out. So I have to write the command data move R0 data out. So whatever the data content in the R0 will be transferred to the data out of the display unit. So that's how we generally deal with the registers of input output devices. In input output devices and memory may have different addresses address spaces, a special instruction to transfer data to and from input output devices. So for example, if I have move in port P0, P0 is any port 0 or pin number zeros in pin number 0, and this port 0 has some of the pins in the microprocessor or microcontroller, and this data will be transferred to a register in register. So basically in register is there, and the data will be transferred to in register. So in the next case, we can see that we are transferring our data to the from R0 to out register. So that is for input and that is for output. So output will out is a command then in which we can do this. Out register is a command, is a register, and the data of the R0 will be transferred to the out register. So input output devices may have to deal with fewer address lines, and so that is an advantage of it. And input output address lines need not be physically separate from memory address lines. In fact, address lines may be shared between input output device and memories, and with a control signal to indicate whether it is memory address or an input output address. So that is the difference between two kind of the um, address address handling of input output devices, the memory. So and now we can check that assessing input output devices has one of the common blocks, and it is input output interface, and this is input device, and we have three buses: address lines, data lines, and control lines. So some address decoder is also there, and in which will decode the address, and accordingly input devices may be any device, device may be any device, and this address decoder will provide some address that which kind of the division device we need to access, and control circuit will provide the state the signals, for example read write signals or wait signals, so that it can be assessed basically very nicely. And in a data and status register has some of the important data registers, and of inside of the device input and output devices, and these data registers are assessed by the microcontroller or microprocessor. So some status registers are also there. For example, flag registers is also there, and these flag registers are accessible by the microprocessor, by which it defines that in which state any device is happening. So if it is in wait state, for example, so it will flag high the um, wait flag. It will hide the wait flag basically, and microprocessor will stop for that case. So input output device is connected to the bus using input output interface circuit, which has address decoder, control circuit, and data and status register. Address decoder decodes the address placed on the address lines, thus enabling the devices to recognize its address. Data registers holds the data being transferred to or from the processor. Okay, so that I have told you that this data we have to take from either from the processor. So one of the important thing that if the speed of the data of all the devices is more than that of the processor, then the device cannot be assessed by the processor. So it is mandatory that that our devices must have lower speed than that of the microprocessor, so for the synchronization purpose. And data and status registers are connected to the data lines and have unique address lines. Input output interface circuit coordinates input output transfers. So so that is the thing. So one of the thing what I have told you, that recall that the rate of transfer to and from input output device is slower than the speed of the processor, definitely, because if this is a different, then the problem will be there, and this creates the need for the mechanism and to synchronize data transfer between them. So program control input output, so we can have two kind of the things. For example, program control, it means in software we have some of the techniques. For example, I have already given you this example here, in which I have passed two commands: move data in R0 and move R0 data out. And these commands are responsible for the to assess the registers and to transfer the register from processor to input output devices and so this is my program control input output, and process repeatedly monitors a status flag to achieve the necessary synchronization, and processor polls the input output device. That is one of the important thing that is described here: polls the input output device. So basically in these cases, our processor basically engaged with a single input output device, and it continuously check the status of the flag, and by which my processor get busy in this, and because of this busyness, the processor capability becomes down, and because unnecessary here it has to work, and it cannot provide a sufficient efficiency of its own. So that's why this is the polling method. So and another methods to assess the input output devices are interrupt methods and DMA, which we will discuss later. In interrupt methods, this is an unwanted signals is produced by the input output devices, and these signals are captured by the processor, and then it works for the input output devices first, and then it works its usual work, or whatever it is a usual work, and it's a routine work. So next we will discuss about the interrupt and the direct memory access. Okay.